or this coordinate plane, we can go ahead and designate this point right there. What's that point considered to be?
Oh, you're counting.
-4, 2. I'm counting the blues as well. So it's -4, +2. Now, as we look at that, we know we designate a coordinate point as the x value first and then the y. The x value is going to be your distance from this vertical axis, how far to the right or how far to the left. And then the y value is how far you are from the horizontal line. Those also have other names though. And I don't know if you're highlighting in your papers or what you do in your notes there. But if you look at it, it says the first, called the x-coordinate or abscissa. So we can also refer to it as this. So if you hear a college professor start to mention the word abscissa, all they're talking about is the x value. It measures the distance from the vertical axis, and the second one, the y-coordinate, called the ordinate. I have to curve that up a little bit to get rid of my second quadrant. Is your distance from the horizontal axis. So if you look off to the left-hand side of page 8, are you able to see points and how they are named? And you're good with that, correct? You've been plotting points for a long time. So the next thing we want to look at then is the graph of a function. The graph of a function f is the set of all points whose coordinates x, y satisfy the equation y is equal to f of x. But how do we even go about drawing the graph? The problem we have is that when you do not know how to graph an equation, for an example, you have been given an equation for a line and you've been able to graph that. If I were to give you, let me just give you an equation real quick and ask you to graph it. If I ask you to graph the following equation, y is equal to 2x minus 1, what would you do? Start at -1, and from there you would go up to and over 1, because you realize that this right here is your y-intercept. And that's where you start your graph at. And then 2 over 1 is the same thing as your slope, which is rise over run. And you know which way a positive slope. Oh, maybe I better spell that correctly. Let me get one less hump on there. There we go. Run, not rum. So you go up 2 over 1, up 2 over 1, down 2 over 1, and you know which direction is your positive slope, so you are able to get it in the right direction, and you have the graph of your line. If you get a different equation though, and you have no idea where to start, and you could do the same thing with this one. Back when you first learned how to graph, one thing they tell you to do is to go ahead and make an XY table, and you just pick values for X. And you're like, well, I don't know, what values do you pick? Well, it doesn't matter. You pick those values. Pick -1, -2, 0, 1, 2. I don't care what you pick. I should have started with -2. But pick those values, put it into the equation for X, and see what your Y value is. If you put -1 in for X, you get 2 times, you're going to get this, 2 times -1 minus 1, which is a value of -3. If you put -2 in, you get 2 times -2 minus 1, and you get a value of -5. If you put 0 in to the equation, you get -1. If you put 1 in, you get 1. If you put 2 in, you get 3. You could plot all those points and connect them, and you should get the graph of your line. If you look at the points, at 0, you get -1, which is what you have right there. At -2, you get -5, which is right there. At -1, you get -3. At 1, you get 1. At 2, you get 3. plot those points and connect them if you don't recognize how to graph it the other direction. You will be given equations in here that you will have a little bit of an idea what the graph should look like, but you might have to generate some points for that and come up with that table. Now realize if you don't get graphing calculators how you're going to have to do it. You're going to have to take the equation and put in each number and solve to come up with the y value. Do you remember what we talked about today in trig class? We got out our graphing calculators and we put this into the y equals equation. When we hit y equals and we type this in, and then you hit second function and hit the graph key, and it displayed this table for you, which is a good thing as long as you get to use those graphing calculators at college. So it will calculate those values for you, you plot them, and you have your graph. Here's the thing though, we have to be able to look at an equation and notice that if it is a parabola, it's going to, the highest exponent is going to be to the second power, it's going to be a quadratic. We got to be able to recognize, is it going to open up or is it going to open down? You have to be able to recognize if it is a cubic equation, something to where the highest power, third degree polynomial. If it's the highest power is to the third power, then your graph will have two turning points. So you need to be able to recognize that your graph is going to do something like that or something like this. Because what you don't want to do is select these points right here and only come up with a portion of your graph and only have this part over here. You have to be able to have enough of your graph displayed that you get the full picture of what your graph is doing. Parabolas are going to be one of the most important ones you use, no matter what area, field of study you probably go into. Because most things either maximize and then decrease, or they're going to bottom out and increase. They're going to have, even the vehicle you drive, there's a point when the vehicle you drive reaches its maximum potential for you, and then all of a sudden it's going to have to start having repairs and it's going to start costing you money. So there's always that maximum height that you can actually reach. Okay, so the next thing that they tell you there then is that in order to graph a function, certain steps that you need to do. First, obtain the coordinates of a few points. So the first thing when we are graphing is we want to create this XY table of a few points. The second thing you want to do is you want to plot those points on your coordinate plane, on the XY axis that you're going to have. And the third thing that you then do is go ahead and connect the points and see what your graph is going to look like. Now, one key thing is when I am checking over these papers, make sure you put those arrows on it. Your graph is going to continue on. If this were a line back here, notice I put the arrows on it because it's going to continue on. It doesn't stop at -2 and stop at +3. It keeps on going. So even if this is a parabola that you are going to graph, it's going to continue on in those directions. So we want to make sure that we include that. On the next page. The best way to do step 1 is to make a table of values. Assign values to x and determine the corresponding values of y equals f of x, which means the same thing. So what they're doing is you're saying you're having here is x, and your output's going to be f of x. That's not any different than saying x and y. As saying CISA and ordinate. Generate that table. The whole 3-step procedure is illustrated in figure 7 for y is equal to f of x, which is equal to x squared minus 3. So the first thing that we would want to do, if we were given the equation y or f of x is equal to x squared minus 3. One thing I hope that you're able to do, because if you go off to college, things that I've seen before when I go to UNL Math Day, I've had people come over to the motel room that night, college students, and they're asking for help with their homework. And one thing that they're doing is they have to recognize what they're going to be, it's online. So they'll have an equation, they'll have a problem, and they'll have an equation up, and then they will have 4 or 5 graphs to select from, which I think you've seen that in some of the ACT review. You have to pick which graph kind of goes with the equation. As I look at this, I hope before you graduate, you're able to look at this and see that since I have this, here's some things you need to keep in mind. Since I have x squared, your graph is going to be a parabola. What's a parabola? It's the U shape. Since this coefficient right here is positive, what does that mean? It's going to be the smile. It's going to open upward. If it happened to be negative, then it's going to open downward. I hope that by the time you graduate, you're able just to see that. That helps with the process of elimination. Now you're down to maybe 2 graphs. If they give you 5 choices, maybe 3, then you need to know a little bit more about translations and what happens to the graph if I say -3. Does that move it up 3, down 3, left 3, right 3? What does it do to your graph? So that then you can select the graph. We might experiment a little bit with those on the graphing calculator so you guys can come up with what you think would happen. But you got to be able to recognize that. Once again, because I don't know how much of those graphing calculators you will get, unfortunately. It was my pet peeve all along, and I finally give into it. And now that after 2 years, after 2 years, now they're saying, no, don't use those calculators. Like, that's what I said in the first place. When you guys were expecting. So given this, we would come up with a table of values. But I have to have enough in order to recognize what my graph is going to do. Could you, for me, get out your graphing calculators? Pause this for a second. They're going to tell you if you want to graph that equation, y is equal to x squared minus 3. You have to create this table first. And you have to pick enough points so that your full graph can be displayed. Now, what's that mean? I got to take that equation, and I'm going to have to put -3 in, square it, and subtract 3. What's the answer? 6. Because -3 squared is 9. 9 minus 3 is 6. Then I put in -2. Now, if you put these in and calculate them because you don't get a graphing calculator at college by some odd chance, like Kaylee Anderson. If you're typing this into your calculator, do you think you're going to get a different answer if you put that in parentheses or if you write it this way? Yes, you are. And you better make sure when you substitute that back in, which goes clear back to Algebra 1, Algebra 2, do you remember I said, oh, if you're going to substitute in, you go x squared minus 3, that's the first thing you do. And then you figure out what your variable has value of and you put it in those parentheses because otherwise you're going to miss a sign. I preached on that 2 years ago to you. A lot. Only 3 years ago to you. So we calculate that and you're going to get 4 minus 3, which is 1. And then I would put -1 in. -1 squared minus 3 is going to give you a value of -2. Then you put 0 in, and you just get -3. Then you put 1 in, and you get -2. You put 2 in, and you get 1. You put 3 in, and you get 6. You have your table. Plot those points. What happens if I don't want to calculate that, and by some odd chance that college professor gives me this graphing calculator? Then what do? You go to, after you've typed in that equation, you go second function graph, which is actually your table. Now for some of us, we have color. It's the same X input, but your Y value is going to be different. The first one that I have in blue, for those of you with color, is that blue equation, which was just X squared. For those of you without, just keep in mind which equation is which. So the first, that Y1 is just
the y values for x squared. If I want the x squared minus 3 equation, you have to look at that next column, which is in red for most of us, or the y with a subscript of 2. Do you get those values that we have up there on the board? Yes. Yes. And then some, right? Because if mine goes from -5 up to 5, you can scroll on yours. But don't, for some of you that maybe have your table set and it starts at 0, then you don't see those negatives. And if you were to graph that, then you're going to get a graph like Reagan had. If I go to my table set and it just has X and Y and it starts here at 0, 1, 2, 3, if you were to plot those, your graph's going to look like this. Does that fully display what your graph is doing? No. So you have to make sure that you pick more plots, or on your graphing calculator, scroll so that you can see that it curves up on the other side and you do get your parabola. Does that make sense? We are okay with plotting points, or do I need to go over that? You can plot points. Final things, make sure you put your arrow tips on there after you connect your points, because it does continue to move on. We're good with that, yes? All right. A partial catalog of functions, page 9. Our first class of functions is class of linear functions, that is, functions of the form f of x is equal to ax plus b. I hope that if you see f of x equal to ax plus b, that looks very familiar. It looks like this: y equals mx plus b, right? Something that you've heard in the past, y equals mx plus b, and you say b is the y-intercept, m is the slope, which is your rise over run, and you can graph from there. Most people, that b, you begin there, and you put it on the y-axis, and then from there you count your slope. You have your graph. Those are linear functions because their graph is what? Those are called linear functions because their graphs are a line. It's a straight line. Hopefully we recognize that. Hopefully we recognize that if it's a positive slope, it goes in this direction, correct? If it's a negative slope, it goes this way. Because if you remember, with our negative slope, forms the end. We talk about an undefined slope. That's undefined. Because if you remember, we can write the word undefined out of it. This slope is what? That is a horizontal slope, which is known as a zero slope. So we would be able to recognize that information. The first thing that they're going to give you for an example is they're going to ask you to sketch the graph of y, which is equal to f of x. Those mean the same thing, which is equal to 1/2 x minus 2. Could you graph that? I'm guessing most of you wouldn't go to the point of creating an XY table. Is that correct? If they ask you for that, you would know how to do that, which I would find to be kind of ridiculous to ask you for that table when you can just come over here and graph it as such. If I wanted to graph it, where are you going to start? -2. And then you're going to have a positive slope where you're going to go up 1 and to the right 2. Bringing back Algebra 2 memories, right? Where all you graphed were lines. Just because that's where you start. The simplest thing that you can graph. Now, I do want to point something out to you. When you start talking about graphs, you have two important things. One is going to be the y-intercept. You can pick that out of that equation pretty easily, I'm guessing. The second thing that you're going to have is the x-intercept. Where does it cross the x-axis at? We have worked with that already with parabolas last year.
That was part of completing the square and some of that stuff. We talked about it. We said what you were finding are the zeros. It's when y is 0. Two important things that you could always graph. If you talk about the x-intercept, what one of these values is going to be 0? Y. Y is 0. No matter what point on this x-axis my graph crosses at, the y value is 0. And when you talk, so this is the x-intercept. What about the y-intercept? What about when it crosses the y-axis? When it crosses the y-axis, any point here where it crosses, x is 0. If I want to know what the y-intercept is, y is going to be a number, because that's where it's going to cross at. X has got to be 0. If I want to know the x-intercept, I want to know where does it cross the x-axis at. You let the other value be 0. You could put that in the equation. That's why we say that -2 is the y-intercept, because x is 0. So if I cover that up, the only value you're left with is -2. To find the x-intercept, y is 0, and you're going to have to solve that equation. How do you solve that equation? You add 2 and divide by 1/2, which means you multiply by 2 and you get 4. Isn't that what our x-intercept is right there? It's 4. Two key things. And if you wanted to graph this, you could just do this right here, plot those 2 points and connect it, because you recognize it's a linear graph. That's an easy way to do it. If you have to create your table or whatever you might need to do, but that's all you really need to do. All right, what I need you to do. I got to get my graph paper out. I'm going to stop talking for just